Part 3, Physics, October-November 2015, Paper 12. Question 19. The table summarizes some descriptions of evaporation. Which row of the table is correct? The first table tells you whether there is a change in state from liquid to vapor. So we all know that evaporation means there is a change from liquid to vapor, so it's true. So the answer can be either option A or option B. Occurs at a fixed temperature. We also know that if it occurs at a fixed temperature, that means it's boiling. If it's not a fixed temperature, that means there is an evaporation. So evaporation takes place at a range of temperature. So this is false. So clearly we know our answer is B. Evaporation takes place at any temperature. When the air molecule strikes the surface, they are going to impact some energy to water molecules. If the energy is sufficient enough to change the phase of water molecule, we experience a phenomenon evaporation. It can occur at any temperature. So you can see it can occur at any temperature. It changes the phase from liquid to vapor. Involves a reduction in the average kinetic energy of the remaining atom. So as we know that our option is B, so the answer should be true. Here is the explanation. Evaporation causes cooling because the process requires heat energy. The energy is taken away by the molecules when they convert from liquid into gas, and this causes cooling on the original surface. So basically what happens when air molecules strike on the surface of the water molecule, if they gain sufficient energy, they will leave the surface of the molecule. It becomes vapor and they leave off. So the overall average kinetic energy of the remaining molecules will decrease. And we all know the average kinetic energy is directly proportional to temperature. So if average kinetic energy of the remaining molecules reduces, that means our temperature decreases. Since our temperature is decreasing, we get a cooling effect during evaporation. Therefore, answer is B. Question 14. The diagram shows the cross-section of an Olympic-sized swimming pool filled with water. It is not drawn to scale. The density of the water is 100 kg per meter cube. So this is a diagram that is a cross-section of an Olympic-sized swimming pool. We need to find the difference in pressure between X and Y. So to find the pressure difference, first we need to find the pressure of this depth. That means from the surface to the point X, then have to find the pressure to this point Y. And when we subtract both the pressure, we'll get the pressure difference between X and Y. So if we have pressure, liquid pressure, we need to use the formula rho GH. Since we are finding the pressure difference, rho, that is the density, g is the acceleration due to gravity, h is the change in height. So the density of water is given as 100 kg per meter cube. G is 9.81. The difference in height, that's the vertical height. This is 2.35 meter minus this length is 2 meter. So the difference in height is 2.35 minus 2.00 meter, which is 0.35 meter. When you multiply, you get this answer, 3,433.5 Pascal. As you can see, all the answers are given in kilo. I'm converting my answer to kilo, which gives me 3.4 kilopascal. As you can see, the option is B. Question 21. A force acts on a wire to produce extension E. The same force then acts on a second wire of the same material but of half the diameter and 3 times the length of the first wire. Both wires obeys Hooke's law. So let's take wire 1 and wire 2. A force acts on a wire to produce an extension E. Let's keep that as Y1. Let me take the force as F and the extension it produces as E. The same force acts on the second wire. So it's going to be the same force. Same material. If they tell same material, that means their Young's modulus is going to be same. So same Young's modulus, but half the diameter. So if I take the diameter of Y1 as D, diameter of Y2 as D by 2. And 3 times the length of the wire. So Y1, I'm taking it as length L, and Y2, I have to have 3 times, so 3L. The question is, what is the extension of the second wire? So I have to make E2 as my subject. Okay, to do this, we can follow one simple method. Since we know the Young's modulus is same, so in this case, wire 1, Young's modulus of wire 1 is equal to Young's modulus of wire 2. Young's modulus is equal to stress by strain. So if you take the stress, if you consider stress, by strain. Stress is force over area, and strain is extension over length. This is your Young's modulus. So I have taken Young's modulus of wire 1 is equal to Young's modulus of wire 2. The Young's modulus corresponding this formula, force is taken as F, length is taken as L, cross-section area is pi r square, so pi is here. Since we don't have radius, but we have diameter, radius is equal to diameter over 2. So instead of radius square, I am taking the half of the diameter into, I'm squaring it. Extension is E. This is for the Young's modulus of first wire, which is equal to the Young's modulus of second wire. So force for the second wire is same F. The length for the second wire is 3L. So I have to multiply force with 3L divided by pi r square. So our radius, as I told you, our radius is diameter over 2. But the second wire's diameter is already halved. So in place of this diameter, we'll substitute d by 2. Because the diameter is already halved, divided by this 2. So I have d over 4. That's here, and r square, because we are squaring pi r square. Cross-section area is pi r square. So I'm taking the whole square. In place of extension, we have to make that as the subject. So we have considered the extension of the second wire as E2. So basically what I have done, I have taken the extension of the first wire equal to extension of the second wire. Why? Because they have already mentioned they are of the same material. Same material means they have the same Young's modulus. And I have substituted the formula stress over strain with the given details. Now we have to just cancel it off. The force is same both the sides, so I can cancel. The length is same both sides, so I can cancel. Pi is same both the side. I can't cancel extension because this is E and this is E2, so they are of a different numerical value, so I cannot cancel it. So since they are all cancelled, I have a squared d by 2 whole square. So it becomes d square. And this 1 by 2 whole square becomes 1 by 4. D by 2 over 2, that is d by 4. When I whole square becomes d square over 16. Now I can cancel few values. I can cancel d square and d square. This 4 with this one, and I get 4, which will go up as a reciprocal. So, and this E2 will come this side. So I get E2 is equal to, when this 4 goes up, 4 into 3 will give me 12E. It's not necessary that you have to follow this step, but I find this method to be easier than all other methods, but you can follow the one that you feel comfortable. So as you can see, the answer is 12E. The option is D. Question 22. Which statement about elastic and plastic deformation is correct? Elastic deformation means if you give a force and if you allow it to stretch, and after a point of time when you remove the load, it will go back to its permanent position. I mean, it will go back to its original length. In that case, you say it as it is elastically deformed. Elastically deformed means when you add a load and after the removal of the load, it will go back to its original length. Plastic deformation means after the addition of load and after you remove the load, it will not go back to its original length. There might be some permanently deformed length, or there will be a permanently extended length that is attached. That means that you have taken to a point where it cannot return back to its original position. So let's read option A. Elastic deformation and plastic deformation are proportional to the applied force. No, that's not correct. Because plastic deformation, it will not be proportional, it will deviate. Elastic deformation, plastic deformation cause no change in volume. They do have a change in volume, so this statement is incorrect. Elastic deformation causes heating of the material, but plastic deformation doesn't. That's totally incorrect. Elastic deformation is reversible. Reversible means it goes back to its original length, so that part is true. Plastic deformation is not. So plastic deformation is not reversible. Once it is permanently deformed, you cannot get the same length, original length. So there is a permanent extension added to the original length. As a result, it is permanently deformed. So that is called plastic deformation. So this part is right. And therefore your option is D. Question 23. What is meant by the ultimate tensile stress of a ductile metal? What is meant by ultimate tensile strength? It is often shortened to tensile strength. It is a maximum stress that a material can withstand while being stretched or being pulled before breaking. So tensile strength or tensile stress, that means the amount of force that you can give to a point before it breaks. So the ultimate force that it can withstand, ultimate stress it can withstand, it is known as ultimate tensile stress. And ductile materials are material that can be drawn into wires. So examples are metals, including gold, silver, copper, etc. Okay, let's read the option. It is the maximum stress at which the material deforms elastically. No, it's the maximum stress before it breaks. So it is a maximum stress at which the material obeys Hooke's law. No, that's wrong. It is the maximum stress that the material can support without breaking. Yes, it is the stress that it can withstand before it breaks. So C is correct. Therefore, the option is C. Question 24. A 0.80 meter length of steel wire and a 1.4 meter length of brass are joined together. So you can see steel and brass, they are joined together. The combined wires are suspended from a fixed support. This is the fixed support, and the force of 40 Newton is applied as shown. The Young's modulus of steel is given, as well as the Young's modulus of brass is given. Each wire has a cross-section area of 2.4 into 10 to the power minus 6 meters square. The wires extend without reaching their elastic limits. What is the total extension? Ignore the weight of the wires. So we don't need to consider the weight of the wires. We need to consider what is their total extension. So we already know Young's modulus is equal to stress by strain. So if you write in detail, you will get force into length divided by cross-section area into extension. This question says the wires extend without reaching their elastic limit. What is the total extension? So total extension of the steel plus the total extension of the brass, that will be the total extension. So extension is equal to extension of the steel. I'm taking it as 1. And extension of brass, I'm taking it as E2. So the sum of both will give you the total extension. So the extension, you can get E as the subject from here. So take this E this side. So extension is equal to force, length, over area into Young's modulus. I've made extension as the subject. So in place of E1, substitute their values for steel. So the force given to steel and force given to brass, they both are same. That is 40 Newton. So in place of E1, write the value of steel. In place of E2, write the value of brass. So both the case, force is same. So I've written 40 and 40. Then length of steel is 0.80 meter. So I'm multiplying by 0.80 meter. To this part, the length is 1.4. Cross-section area is same for both, which is 2.4 into 10 to the power minus 6. And then I have Young's modulus. Young's modulus of steel is 2 into 10 to the power 11. And for brass is 1 into 10 to the power 11. So I'm taking these values using a calculator. Sum it. You get 3.0 into 10 to the power minus 4 meter. Therefore, the option is B. Question 25. Which of the following wave motion may be used to demonstrate the phenomenon of polarization? So first thing, we need to know what is polarization. So polarization is a phenomenon where your particles in a wave vibrate in only one position. And it's a unique property of transverse wave. So when you talk about organ pipe, it's a sound wave. It's something to do with a longitudinal wave. So longitudinal waves cannot be polarized. Thunderclap, that is also a sound wave, so that's a longitudinal wave. So the only option we got is B and D. A surface wave in a water ripple tank. The surface wave is easier to demonstrate interference and diffraction, but it is not that easy to show polarization. But when it comes to stretch string, when you have stretch string, it will vibrate, so it forms a transverse wave because it vibrates to and fro. So as a result, it can be polarized. You can show the polarization properly. So therefore, your option is D. Question 26. The diagram shows the screen of a cathode ray oscilloscope, CRO, displaying a wave. The time base of the CRO is set at 10 millisecond per division. So time base 10 millisecond per division, which means in your x-axis, one division corresponds to 10 millisecond per division. So one division is 10 millisecond. So if I have to talk about my time period corresponds to one entire wave. So I have 4 plus a little bit more. I can say 4.25 division. So into 10, so that will give me 42.5 millisecond. Because one complete wave takes around 4.25 division, one division corresponds to 10 milliseconds. So this entire one wave corresponds to 42.5 milliseconds. The question is, what is the frequency of the wave? We know that frequency is the reciprocal of time period. So 1 over time period, we already found 42.5 milliseconds. So 1 over 42.5. For milli, the prefix milli is 10 to the power minus 3. So I get the answer as 23.5 hertz. So when you round it off, it becomes 24. So your option is D. Question 27. P is a source emitting infrared radiation and Q is a source emitting ultraviolet radiation. The figure in the table are suggested value of the wavelength emitted by P and Q. Which row is correct? We need to remember the wavelength value. I would suggest you either remember the wavelength value or the frequency value. Don't remember both at the same time. I mean to say you need to remember the power of 10. So if you know the wavelength value, then you can use V is equal to F lambda and get the frequency value. Or if you know the frequency value, you can get the wavelength value using this formula. As we know, the electromagnetic wave all travel in the speed of light. We know V, we know one of them, you can find the other one. So here P is infrared, that's here. And Q is ultraviolet, that's UV. So infrared is 10 to the power minus 5. So it can be either this value or this value. Ultraviolet is 10 to the power minus 8. So that's this value. So the only option we got is option A. Don't forget, before you go to your exam, make sure that you learn this table. Take a note of it right now, so that you'll not lose marks in such easy questions. Question 28. The diagram shows a tuning fork above a tube of air of length 25 centimeter. So this is a tuning fork. This is a tube open to air. One side is open, which is 25 centimeter. A stationary wave is set up in the tube with the same frequency as the tuning fork. The lower end of the tube is sealed. This is the minimum length of the tube with the lower end sealed that creates a stationary wave. Which are the lengths of tube sealed at their lower end will also create a stationary wave. So it's a closed tube. I'm sorry, it's an open tube. No, if it's an open tube, both sides should be open. If it's a closed tube, one side should be closed. So this is a closed tube. Remember one thing, when a stationary wave is formed on a closed tube, the place where it is sealed, you will get node. And wherever it's open, you will get antinode. And they have mentioned this is the minimum length of the tube that produces this stationary wave. So this 25 centimeter, this first diagram should correspond to the fundamental mode of vibration. So the very first diagram you can obtain is with one antinode at the open end to the node at the other end. So now you have this diagram. So we know that this is lambda by 4 because node to the other node, for example, if you have a stationary wave, this is node to node. That is half wavelength, half lambda. You have antinode here. So this is half of the half lambda. So node to antinode is lambda by 4. So this 25 centimeter corresponds to lambda by 4. So we know that now that lambda is equal to 4 into length. Our length is 25 centimeter into 4 will give me 100 centimeter. I need to find another 2 lengths that can create the stationary wave. So the second diagram looks like this. Since the closed end starts with node, the open end ends with antinode. The next diagram, that is your second mode of vibration, should look at the other antinode. So the next possible diagram that you can draw is with another antinode. So you've got another antinode. So this up to this is lambda by 2. And node to antinode is lambda by 4. So you get L is equal to 3 lambda by 4. We know the value of lambda is 100 centimeter. So just substitute the value. 3 into 100 by 4. One answer is 75 centimeter. The next possible diagram is another antinode added. So you can see this up to this, it's one complete oscillation lambda, and node to antinode is lambda by 4. So lambda plus lambda by 4 will give 5 lambda by 4. In place of lambda, we have 100 centimeter. So 5 into 100 by 4, 125 centimeter. So we got 75 centimeter. And also 125 centimeter. So clearly, our answer is D.